On September 12th, 2025, astronomers spotted something truly incredible. A gigantic object from deep space just showed up, and it's heading for 3I Atlas, and it's 100 times more massive than 3I Atlas. This discovery set astronomers going absolutely wild across the globe, because it was not discovered by NASA, nor by the SA, but by an amateur astronomer. Using images from a satellite that wasn't even designed to look for comets, Vladimir Bazugli, watching solar wind imagery from the SWAN instrument aboard Soho, noticed something peculiar. A faint, fast-moving dot just barely visible in the corner of the heliosphere. It didn't stay faint for long. Within just hours, observatories confirmed that a new comet had entered the inner solar system. But this wasn't just any comet. This one was unusually bright, unusually fast, and by some early estimations, potentially 100 times more massive than an interstellar object already passing through our neighborhood. And the name of this newfound discovery is C2025 R2 Swan. Today, science prepares for another chapter in the great story of space exploration. And this is the video of how a faint ghost from the outer reaches of our solar system is suddenly taking the world by storm. Comet C 2025 R2, nicknamed Swan after the instrument that spotted it, is a long-period comet. It doesn't orbit the sun every few decades like Halley's Comet. Instead, it's a deep freeze relic from the Oort cloud, a spherical shell of icy bodies that surrounds our solar system nearly a light year away. Initial orbit calculations suggest Swan completes a single loop around the sun only once every 22,000 years. That means the last time it passed through the inner solar system, humans were still painting on cave walls. What makes it even more fascinating is its trajectory. Swan didn't drift in gently. It plunged inward fast, swinging around the sun at a distance of just 0.5 astronomical units, or roughly 75 million kilometers. That's closer than Venus. And as it neared the sun, something dramatic happened. By mid-September 2025, just days after its confirmation, observers began noticing something astonishing. Swan wasn't dim. In fact, it was visible through binoculars. Its coma glowed green, a sign of diatomic carbon gas fluorescing under sunlight, and its tail stretched across the sky, resembling a spiral corkscrew. Some early reports estimated the tail at 5 degrees long, over 10 times the width of the full moon. It was no longer just a comet. It had become a spectacle. Photos from ground-based astronomers captured a glowing emerald head, with jets of gas spiraling off into space. The tail shimmered in long exposure images like a trail of cosmic smoke. Some researchers began to speculate, could this become the great comet of our time? In fact, many people mistook it for the much-hyped interstellar visitor 3I Atlas. But what they were seeing, what was dominating the night sky, was Swan. And in every way, it was stealing the spotlight. As Comet Swan brightened unexpectedly and its strange, spiraling tail stretched across the sky, a very different kind of question began circulating, one that sits right at the edge of mainstream science and speculation. What if Swan isn't natural? What if it's something engineered? It's not the first time this idea has been floated in modern astronomy. In fact, when the first interstellar object Oumuamua passed through the solar system in 2017, its unusual acceleration and lack of a visible coma led Harvard astrophysicist Avi Loeb to suggest it could be a light sail, a piece of alien technology propelled by starlight. Since then, every new and unusual visitor to our solar system has drawn scrutiny, especially when it behaves differently than expected. Now, C 2025 R2 Swan has triggered similar questions. While most scientists view it as a typical long-period comet, a few anomalies have caught attention. For one, Swan brightened rapidly in a very short period, faster than most comets of its kind. Its tail is unusually structured, with some observers noting a possible corkscrew pattern that doesn't entirely match known outgassing behavior. And then there's the trajectory. While consistent with the comet from the Oort cloud, some early tracking data showed minor deviations that some theorists speculated might suggest controlled motion, or at the very least, an interaction with unknown forces. While these observations are still within the bounds of natural explanation, like asymmetric outgassing or fragment ejection, the alien spacecraft theory continues to surface in discussions, not as confirmation, but as a provocative possibility. Skeptics are quick to point out extraordinary claims require extraordinary evidence, and to date, no firm data indicates that Swan is anything other than a comet. But supporters of the theory argue, if alien probes were to be sent to monitor developing civilizations, using dormant comets as cover would be a smart strategy, stealthy, recurring, and difficult to detect unless someone looks closer. Could Swan be such a probe? Probably not, but in a universe with billions of stars and countless comets sailing through interstellar space, it's a question that lingers. And sometimes, the value of a theory isn't whether it's true, but whether it forces us to look deeper. For context, 3I Atlas, the third known interstellar object, was discovered just 2 months earlier, in July 2025. It came from outside the solar system, moving at an incredible 209,000 kilometers per hour. At first, 3I Atlas appeared bright, leading to wild speculation about its size. Some even floated the idea of it being an alien probe, but deeper analysis from NASA and Hubble showed a modest nucleus, likely under 5.6 kilometers across. A fast-moving, icy fragment, interesting, yes, but not particularly massive. Swan, by contrast, appeared dramatically larger. Some estimates suggested it might be tens of kilometers wide, though this is still unconfirmed. But based on its brightness and tail structure alone, it was clear Swan was the more visually stunning of the two. And that's where the rumors began, that the object 100 times more massive might collide with the interstellar one. It didn't take long for the internet to spiral into theories. A massive object is on a collision course with 3I Atlas. Some headlines screamed, it sounded apocalyptic. But the science tells a different story. Astronomers quickly confirmed there is no chance of a collision. 3I Atlas came in from the direction of Sagittarius. Swan came from Aquarius. Their paths don't intersect, not even remotely. In fact, their closest approaches happen weeks apart, and they're separated by tens of millions of kilometers. Swan comes closer to Earth, about 0.26 astronomical units or 39 million kilometers. 3I Atlas remains far beyond Mars. So here's the real question. Is Swan just another comet, or is it a once-in-a-lifetime show? The truth is, no one knows for sure. Comets are notoriously unpredictable. Sometimes they surge in brightness as they approach the sun. Sometimes they disintegrate and vanish. But so far, Swan is behaving unusually well. By late September, some observers began predicting a peak brightness of magnitude +4, faintly visible to the naked eye in dark skies. Others remained cautious, predicting it might plateau at magnitude 6 or 7, binocular territory. One thing is certain, the best time to observe it is October. It will appear low in the southwestern sky just after sunset, not far from Mars and the bright star Spica. There's another twist to Swan's journey. Earth may pass through its debris stream around October 4th to 6th. If that happens, and it's still uncertain, we could witness a new meteor shower caused by a comet humanity has never recorded before. Unlike the annual Perseids or Leonids, which come from well-known parent comets, this would be Swan's first contribution to Earth's sky. Beyond the visual spectacle, Comet Swan is scientifically significant. It's a pristine object carrying frozen materials that haven't been altered since the formation of the solar system. When Swan heats up near the sun, those materials vaporize and enter space, allowing astronomers to analyze the chemistry of the early solar nebula. Each time a comet like Swan appears, it gives researchers a brief window into the past, a glimpse at the ingredients that once swirled around our young sun. And because Swan came from the distant Oort cloud, it represents a part of the solar system that's still largely mysterious. Studying it could help us understand how comets are born, how they evolve, and what secrets they might hold about Earth's own beginnings. In the coming weeks, Comet Swan will continue to evolve. It will brighten, shift position, and eventually fade as it escapes back into the shadows of the solar system. We don't know exactly how bright it will get. We don't know if the meteor shower will happen, but we do know this. In October 2025, you'll have a chance to witness something rare, raw, and real, a cosmic traveler burning across the sky. So grab your star maps, pull out your binoculars, and when the sun sets, look to the southwest, because something ancient, something massive is here, and it won't be back for another 22,000 years.